Sketch the rational function y is 3x squared over x plus 1. So I'm going to do a division because the degree of the top is 2, degree of the bottom is 1. So let's do a division. There's more on how to do divisions in the complex numbers section. I'm going to have 3x squared and I have to fill this in with a 0x and a 0. X to get 3x squared, well, I'd multiply it by 3x. Then I multiply the 3x by x plus 1 and I get 3x squared plus 3x. If we now subtract, we get negative 3x, bring down the 0. X to get negative 3x is negative 3. Multiply the negative 3 by x plus 1, negative 3x, take away 3, and then if we subtract we get 3 here. So that's our remainder. So we can write y as 3x take away 3 plus the remainder 3 over x plus 1. Now this part identifies for us an oblique asymptote. Y is equal to 3x take away 3. As x becomes very, very big, the fractional term would tend to 0. And that's why we get left with the 3x minus 3. We've also got a vertical asymptote, which would be x equals negative 1, which we can identify either from there or from the original. If we look back at the original as well, we can see that when x is equal to 0, y will be equal to 0, and therefore this one is going to go through the origin. Now with this one I might just differentiate. So u is 3x squared, v is x plus 1, du dx is equal to 6x, and dv dx is equal to 1. And so dy dx would be equal to v du dx, 6x, x plus 1. Take away u dv dx, which is 3x squared, all over v squared, which is x plus 1 squared. So we get 6x squared plus 6x minus 3x squared over x plus 1 squared. And that gives us 3x squared plus 6x over x plus 1 squared. Now, for dy dx to be equal to 0, to have a turning point, that means that 3x squared plus 6x must be equal to 0. 3x, x plus 2 is equal to 0. So x is 0, or x equals negative 2. Okay, great. Well, that means we've got lots of information that we can use for our sketch. So let's start going through it. So vertical asymptote, x equals negative 1. Oblique asymptote, y is 3x take away 3. So that is going to go something like that. Okay, now we might have some regions to think about here. Well, if we look at x squared doesn't change sign, it just becomes 0. So the only place that we can actually change is at negative 1. So the top's always positive, the bottom's negative to the left and positive to the right. So we know that it must come in from the asymptote here and then head down that asymptote. And that fits with us knowing there's a turning point there at 2. Now we also know that it goes through the origin. We also know that's where the turning point is. So it must come down here, take its turning point there, and then head up the asymptote like so. So it's a bit of a detective game. We put all these pieces of information together to get our graph.